In this class, we are going to study about constructing push-down automata for the given language. So the example problem is construct a PDA that accepts the language L equal to A power n, B power n such that n greater than or equal to 1 where sigma, which is A comma B, sigma equal to A comma B. So for this particular language, we are going to construct the PDA. So first thing is, we have to write the constraints for this language. What are the constraints of this language? From the question, we can understand that what are the constraints of the language. So the first constraint is number of A's equal to number of B's. Number of A's equal to number of B's. And the second constraint is A's should followed by B's. A's should followed by B's. And the third constraint is n greater than or equal to 1. That is, it must have at least one n. Okay, so based upon these three constraints, we can develop the strings of the language, right? So in our language, it's having A power n, B power n. So same number of A's followed by same number of B's. So now we can write the strings of the language L equal to. So if you are giving n equal to 1, we will get A, n equal to 1 and B, A, B is on string. A, B, B. So same number of A's and same number, equal number of B's. So A, B, 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 and so on. Okay, in this way we can write the strings of the language. Then we have to develop the logic for this particular problem. What is the logic is? Logic of the push-down automaton. Okay, so in our question we are having the logic like A power n, B power n. So that means we have to develop the logic for this. So when we can develop the logic like whenever we are getting A's, we are pushing it into the stack, and whenever we are getting B, we are popping it out from the stack. So this is the logic we are designing for this particular language. So whenever getting A, push it, and whenever getting B, pop. So this is the logic we are developing for this particular problem. Okay, so we can see we will take this string W equal to A. Okay, sorry. We'll write W equal to A, B, B, B. I'll explain it with the stack. So simply we will draw the stack here. So but in push-down automata, Z0 is always in the top of the stack. So initially it will have Z0 in its stack. So now I'm writing without adding the Z0. So you can see here, whenever I'm getting A, pushing it into the stack, whenever getting B, another one A, pushing it into the stack, whenever getting another one A, pushing it into the stack, and whenever getting a B, popping it out, one A from stack, and whenever getting another one B, popping it out from the stack, and whenever getting another one B, we are popping it out from the stack. Okay. So now our stack will be empty. So we can understand that our string will be accepted. So now we are going to develop the push-down automata for this language. Okay, so how can we design the push-down automaton is, first we are having a starting state, that is I am taking it as Q0. Q0 is the starting state. Now we have to draw the transitions. Okay, so I am drawing the stack of this push-down automaton here. So we know that Z0 is always in the top of the stack. Z0 is always in top of the stack. Okay, so our string is W equal to A, B, B, B. Okay, so okay, now we can see we are first reading the first symbol, that is A. Okay, so whenever we are getting an A, we are pushing it into the stack. Okay, so initially while reading the symbol, just imagine like we are holding this Z0 on our hand, and then while it is reading the symbol A, we are pushing both of it into the stack. Okay, so in that manner you have to understand. So initially we are holding this Z0 into the stack. While it is going to read the symbol, this Z0 is initially out, and while after reading the symbol A, while we are pushing it, we are pushing this Z0 as well as this A into the stack. Okay, so in that manner we have to draw the transitions also. Okay, so in here what it is going to read, it is going to read A. Since we are going to read multiple A's, A is followed by B's, we are going to read multiple A's. I put this in loop. Okay, so what is the input symbol? A. The input symbol is A. What is in the top of the stack? Z0 is in the top of the stack. Initially Z0 is in top of the stack in that manner. So while it is reading the symbol A, we are pushing both of it into the stack. Okay, A, Z0. Okay. And then next one is in this state we are continuously reading. We are only developing the logic, right? So whenever we are getting an A, we are pushing it, and while we are getting a B, we are popping it. So while we are reading the B, we have to go to another one state. Okay, so the next transition is, so now we are having in the stack, we are having A and Z0. Okay, and when we are reading another one symbol, that is A, we are again pushing it into the stack. Okay, A, the input symbol is A, and what is in the top of the stack? Top of the stack is A, and now we are pushing both A's. So just imagine like before reading the symbol, we are holding the this A on our hand, and while after reading this symbol, we are pushing both of it into the stack. That is the logic. Okay, and then again we are going to read the symbol A. And we are pushing, the logic is whenever we are getting A, we are pushing it into the stack. So we are pushing it into the stack, and then the same logic. So for this A also we are having the same transition. That is, whenever we are getting reading the input symbol A, and the top of the stack is A, and we are pushing both the A's into it. Okay, so no need to write it again, because for this A also we are having the same logic. Okay, now everything is pushed inside the stack. Now next symbol we are going to read is B, right? We are going to read another one symbol, that is B. Now while it is reading another different symbol, we have to, that is the while pushing, we are giving it in the same state, and then while we are doing another one different operation, we are going to another one state. Okay, so now it's going to read the symbol. For this particular problem, we have developed the logic like that. Okay, so now you can see that now it is going to read the symbol B. Okay, now it's going to read the symbol B. So we know that in our logic we are having, whenever we are getting B, we are going to pop one A from that. Okay, so we know that while it's going to read another one different input symbol, we have to go to another one state, that is Q1. So now we will write the transition also. So we know that it's going to get more B's over here, isn't it? So it's going to get more B's over here, more than one B. So we are using this looping over here. So the symbol it is reading as B, the input symbol is B, and then top of the stack is what? Top of the stack is A. And what we are doing, if we are getting, if you are going to read B and the top of the stack is a different symbol A, and what we are going to do, we are popping it. So for popping we are using the epsilon symbol. Okay, so in that manner you have to understand that. So first B is over. Now we are popping the first A out. Okay, now while we are reading B, we are popping one A, and then for the next B also, same logic. We are going to read the input symbol B, and what is in top of the stack? A is in top of the stack, so we are popping it. Okay. And for that no need to write the transition again, because same transition only. Okay, so same transition is used here, so no need to write it again. And then also the input symbol is B, and top of the stack is A, so we are popping it. So no need to write it again and again 3 times. Okay. Now almost everything is over, right? So we have completed reading our symbols. Okay, what is the next symbol here? We are not at all having anything, right? So simply we can say it's epsilon. Okay, so next it's going to read epsilon, nothing, isn't it? So in that while it's reading, so simply we can say the next input symbol is epsilon, right? The next input symbol is epsilon. So while we are reading an epsilon, input symbol epsilon, and top of the stack is Z0, we can understand that it reaches to the end of the string and the string is accepted. Okay, so we know that in PDA there are 2 types of acceptance of a string. That is either it will reach to the final state, or we can empty the stack also. So in the 2 types we can accept a string. So we know that the next symbol is epsilon, right? So epsilon, this next symbol to read is epsilon, and top of the stack is Z0. While it is going to the final state, we can say that epsilon and Z0. So simply Z0 will be there. So while it is going to, while we are accepting the string, while reaching the final state, we have to put like that. Like this. Okay, so epsilon, and input symbol is epsilon, and top of the stack is Z0, and what will be remaining in the stack? Z0 will be remaining in the stack, and it is moving to the final state. So this is one way of acceptance. Okay, so this is one way of acceptance of a string. So while we are saying epsilon and top of the stack is Z0, we can say the string was accepted. And another one method is no need to go to this, no need to go to the final state. Another one method is no need to go to the final state. You just forget about this. So how can we know that in pushdown automata the acceptance will be by reaching final state or emptying the stack, empty stack. So these are the 2 methods for acceptance of a string in pushdown automata. So how can we do acceptance by empty stack? What we can do, so sorry we haven't written here, while state transition is coming here, so listen. So while state transition is coming here, we have to write this also, because for one B this is the transition, and for multiple B's this is the transition. Okay, so while we are moving from one state to another state, for 1B this is the transition, and for multiple B's this is the transition. Okay, same only, no changes there. Okay, so how can we accept a string using emptying a stack? You listen here. Okay, so consider that, like if all the strings are we completed reading all the strings A, B, 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 Z0 will be in the top of our stack, right? So Z0 will be in the top of our stack. At that time what we can do is, if you are going to accept the string using emptying the stack, means how can we accept this? So you just forget about this part. So you just forget about this part and only consider this one. So how can we accept this? In this way we can accept. So what is the symbol we are going to read? Finally epsilon, right? What is in the top of the stack? While we are z0 is in the top of the stack, in that case we can pop it also. So if we are popping it in this state, we can say that this is, and now what will happen? While we are popping this z0, our stack will be completely empty. Our stack will be completely empty and nothing is in our stack. So in this way also we can accept. So there are two types of acceptance in pushdown automata. Reaching final state, that is one. So while reaching final state, this transition will not come, and while emptying the stack, this is the transition. Okay, so up to this we can complete. Okay, so the remaining we are having instantaneous description also. I will complete it in the next part of this video. Thank you.